Hello and welcome to another Rygate Maths video. My name's Simon and in this video we're going to be looking at mathematical modelling in the context of quadratic functions. So what is mathematical modelling? It is taking any real life situation, turning it into some mathematical equations or arguments so that we can perform some calculations on those. Quadratics are a really good way to do a very simple model for some quite complicated ideas. And you'll see kind of some common themes with quadratic modelling. Another big part of modelling in the A-level is you need to be able to criticise a model as well. So let's jump straight in and have a look at an example. So we can see here a ball is being kicked from a platform above the ground and we're given some information about the equation. Now in this case we're given our equation, our model, but you might not be given it, you might have to come up with it yourself. So let's just have a look at some kind of quite important features that you might have to pay attention to. Okay, so we're told the height is h meters and we're told the time is t seconds, and then we're given this quadratic function. We're also given this. Now, from the previous video on functions, we called this the domain. So this is the set of values that we are going to be putting into this equation. And although it's not part of this particular example, you might have to explain it. So in this case, t is greater than or equal to 0. And for here, you have to think about what does t actually represent. So t is time. So we can't have a negative time. So t has to be greater than or equal to 0. And there might be some other criticisms that we can make about this model later on. Now something that's quite useful to do is draw a diagram. So we've got a negative quadratic, so it's sort of doing this. And we've got kind of a platform and then the ground. So a very, very simple diagram. So how high is the platform? Well, we've got this distance here, so that's what we're trying to work out. Now, having a diagram is all well and good, but if we can't relate it to the model and to the sort of maths, that's not particularly helpful. So let's think about this as an equation or as a graph. So we've got t equals 0 here. So this is the y-axis, and then this is our x-axis or our t-axis. So this is h and this is t. So our starting point is what we're interested in. Now our starting point is how high the platform is. So we can think, okay, well our platform is where we start, and we start when t is 0. So when t is 0, h is 3 plus 2 times 0 minus 0 squared, which is 3. Now getting h as 3 is not enough. We need to relate it back to the context of the question. So therefore the platform is 3 meters high. So you do have to be careful. We're talking in meters, so make sure that your answer includes meters. You don't have to write meters. Having m as meters is fine. So what is the maximum height the ball reaches above the ground? So that's going to be here. And there's a couple of ways we can do that. But the simplest way is thinking again about this as a quadratic graph. This is the vertex. So if we think about completing the square for h, then we can work out the vertex. So if we take out a minus from the bits with t in and leave the 3 alone, we then complete the square here. And then put the minus back in, we get 4 minus t minus 1 squared. Now the vertex, we can see the t value is 1 and the h value is 4. So what this means is, so this is 1, this is 4, so therefore the maximum height is 4 meters. Notice how we haven't really done anything different from anything else in the quadratics topic, we're just doing it in context. So how many seconds after the ball has been hit, so remember it's hit here, does it hit the ground? So we want this. And oh look, that's when h equals 0. So we're just solving a quadratic equation. So 0 is going to be 3 plus 2t minus t squared. Let's rearrange that to make it a little bit easier for us to solve. Whoops. That's something that students will often do by accident. Make sure you're staying consistent with your variable. So we're using t, so keep t in. And we can see that this does factorize quite nicely. Now we do get two solutions, which algebraically is fine. But again, we've got to relate it back to the question. T is time. So the ball hits the ground after 3 seconds. Where does this -1 come from? Well, if we extended the graph and thought about it as a graph, it crosses the x-axis here. Now, something that you might have to do, and I'm adding as a part D, is criticize the model. So what makes this model not very good? And there are lots of possible reasons that you might want to criticize or evaluate the model, but always look at what you've calculated. And a big one is this 3 seconds. And looking back to our domain. So our domain, the acceptable values of t is just that t is greater than or equal to 0. But what happens if t is bigger than 3? Well, if we think about the graph, if t is bigger than 3, the graph keeps doing this. So it goes underground, which doesn't make sense. So that is a criticism of the model. For t is bigger than 3, the height above the ground is negative. Which doesn't make sense. So therefore, the model is not valid, or the model is only valid for values of t between 0 and 3. And this is a really good criticism of the model. We're not only saying the thing that's wrong, we're also fixing it, which is something that you might have to do. Now, modelling comes up in a lot of different contexts, and it's a big feature of the A-level. In fact, it's an entire assessment objective. Being able to use a model and criticise the model in the pure side of maths, the mechanics, and the statistics is something that you are going to have to do. But it all boils down to this same idea of doing maths that you know how to do, and then thinking about what could make the model better. In other videos on this channel, we are going to be looking at different types of modelling, so you can go and find those. There's many different modelling contexts for lots of different topics. So feel free to go and have a look at those. But otherwise, thank you for watching.